Cool. So this is Postgres security for application developers. So let's get started. So this talk is going to be about application security. That's in contrast to DB security or user security. So to kind of go into the distinction between these, DB security is about locking down your database. So there was a great talk yesterday by Joe Conway about the things you can do specifically to lock down your database to PGA, HBA.conf, and configurations at the OS level. So that's what I call DB security, because it's specifically locking down the environment itself around the database, and everything else kind of touches on that, but it's a it's a specific subset of security. Now, separate from that, you also have user security, which is about when once you have an application up and running, you have users on your team who need to query something for reporting or just diagnosing something that's wrong, and locking down that access and auditing activity feeds, things like that. So my company actually has a product for that specific use case, but that's not the subject of this talk. So this talk is specifically about application security, which concerns with as an application, how do you talk to your database? How do you make sure that when clients are accessing your application and you're interfacing with your database, how do you prevent bad things from happening? So just a kind of quick intro of for myself. My name is Sehrope Sarkuni. I'm the founder of JackDB. I contribute to the JDBC driver and to the Postgres driver. And every so often I'm on IRC as Sehrope, so usually giving good advice. So good security, they say it's like an onion, and not because it makes you cry, but because it has layers. So what's it mean to have layers in security? Yeah, there's this concept of defense in depth, where to get into this castle, you're not just you can't just walk in. First, you have to get through the moat, and then you have to get over the wall, then you have to get over the next wall, and each step in between, hopefully, is independent from the steps before. And to get all the way through, you have to to get to whatever's on the inside, you have to get through all these barriers inside. So this is what's the just overall concept of defense in depth. Now, one of the major things in the concepts in defense in depth is limiting the power to do something bad. So this is called the principle of least privilege. So anyone who has kids will recognize this picture as something that's really, really bad. Children should not have access to sharp objects that they can poke themselves with. And the kind of equivalent for databases is if you shouldn't be able to do something that can break something unless you really need to be able to do that one thing. So when you're looking at the way an application interacts with a database, there's really three overarching things that you do. You're either reading something like a select statement in a query. You're changing something, which could be an update, it could be an insert, it could be a delete, like some modification of the data itself inside that database. Or you're changing the overall structure. So that's like a database migration. You're altering a table to add a column, you're dropping a table, creating a new one. So when you look at real-world examples of how people build applications, almost everyone, when they're first starting out with the system, has that one account. So you create a user, then you create a database where the owner of that database is that user, and that guy can do everything. Which is great when you're first starting out, but that also has the problem that that guy can do everything. So that convenience becomes kind of a security hindrance. Now the next level is you start splitting things out and saying, okay, let's have one guy who can handle read-only access, and we'll have a separate account, that original account, that can do everything. So between these two, I still have that full functionality. But if I want to be able to restrict the read stuff to a lesser role, I can use that read role for that. Now, the next level for this is my personal favorite as far as convenience and security mixing together, is where you have a read-only account, and then you have a secondary account, which is kind of a read-write account, like a DML account. And then you have that third account again for doing everything else. So I need to create a new table, I need to run a DB migration or whatever. And this split out, the reason I refer to this as the sweet spot is because it's simple enough to kind of apply to any application. It's not that complicated to set up either. Now, when you go beyond this, then you start getting into like the enterprise kind of setup for things where you'll have this data set has this account, that data set has that account, I can change it with this, run migration with that. And there's really no limit to how many accounts you can have at this point. So it's kind of its own category. And if you're in this world, more than likely you're in that world of having to deal with things like that. So in that kind of sweet spot setup, if you break it down to actual DB permissions, that first account, that app read, all it has is the select permission. So whatever tables we're going to be querying, it has read-only access to it. Then we have this app DML account, which it can do it's a superset of the permissions for the read account. So you have select permissions, but you can also do inserts, updates, deletes, and modify the data inside of our system. And then finally, the app account itself, which is the reason it's named like that is to match up with the database because it's semi-convenient from PSQL to log in. And you can do DB migrations. You can do creates, drops, alters, and all those permissions. So to actually set this up, here we're creating like 3 different users. We have app read, app DML, and app, and then we create our database, which is also called app, with the owner being our app account. So one thing kind of looking at this, if you jump back to the actual passwords inside the example over here, they're not particularly good passwords. So like, you could say, yeah, it's got a letter, it's got a number, or whatever it is, but these are actually very, very terrible passwords. If you spent like 10 seconds staring at this, probably everyone in this room would be able to memorize at least 1 or 2 of these, and you're not going to forget it afterwards. And that's not how passwords should work. So there's a lot of ways of authenticating with Postgres, and passwords aren't necessarily the best way of authenticating with a database. But they're the most ubiquitous way of identifying with it, particularly if you're using like a cloud environment where they're provisioning your database for you already in advance. That might be the only way you're kind of logging in. So if you are going to be using passwords, it's a good idea to have a little bit of control over how you're setting them up. So if you are generating passwords for your user accounts, the passwords should be cryptographically random. They should be long, because the only thing that makes a password strong is how long it is. And if you just want a general rule of thumb, if you can remember the password, it's probably a bad password. So if you want a really quick and dirty way of generating passwords, if you run this on basically any Unix type environment, this will just generate random characters using like alphanumeric choices. So this would generate 32 characters with 62 choices each. So it's like uppercase, lowercase, and numbers. And you'll get things that look like that. So this is actually useful for like passwords, for API keys, like something that you want to generate that you're not going to remember. Because if you can actually remember these strings down there, you have a much better memory than I do. So kind of jumping back to the permissions for the application itself now. So Postgres is actually pretty cool when it comes to permissions, because besides just granting permissions to a user to say that this user can access something, you can also create the permissions on something to be able to have it be ongoing. But to get there, you first have to remove the default permissions. So by default, Postgres lets any account that can log into the database create objects inside of that public schema. So it's like that for, it's very convenient to use once you get set up. But you don't really want that, because if you're going to split this out into separate groups, you want to have that locked down so that permissions only in a specific, on a specific user. So these first 2 things we're doing up here is we're revoking the access to be able to do anything in that public schema. And then we're adding back the ability to specifically just to view the catalog for the schema. So the first step in security in Postgres is, can I see the object I'm trying to access? And that's what that grant usage is doing. Now the other 2 lines below, the first one is saying grant access to all the tables in that schema to the app read. If you're starting out with an empty database, it's not really doing anything because there's nothing to grant, but we put it in there just to show how you would kind of migrate to this kind of setup. And finally, the last one over there is that point I was touching on, where I'm saying the default privileges for anything created in public automatically granted to the app read. So I don't have to go back and grant again that this user can select from this table. I can just create the table, and they'll be able to access it. That's kind of like a general principle in security, that if you make it easy to use, people are more likely to actually use something. Because now I don't have to think about granting read access to something. I just have this read-only user. So for the DML account, it's a very similar setup. The difference now is instead of just select, I'm granting insert, update, and delete in there. And again, the default privileges are set up for that account to be able to do the same kind of permissions on top of there. So for the app user, I don't have to do anything. By default, the app user can do just about anything inside the database. But it's not a super user. And you more than likely don't want it to be a super user, because if you're a super user, it kind of bypasses a whole bunch of other security checks. And you just don't want to happen. Again, the idea is you want to lock things down to whatever the bare minimum is. So I can do DB migrations, I can alter columns and stuff with this, but I'm not going to dynamically install extensions or something using this user. So if I'm actually going in and I want to provide this to my application, you need to inject in these credentials somehow. So the kind of standard way to do this is to have environment variables for the for each user. So I have one for read, I have one for DML, one for DDL. And in whichever part of the application I'm going to be using something, I'll pull out whichever environment variable I want to connect to the database as that user. But one thing to keep in mind for this is, if I'm not going to be doing something, I probably shouldn't have it in there in the first place. So that that DDL permission I have, I might need it for running DB migrations, but there's no reason at runtime my application actually needs those permissions. So it might be convenient just to have everything in one place. But if I don't provide it to the application at runtime, I never have to worry about being able to drop my, accidentally dropping a table because of some other bug inside of my application. So again, this is the whole concept of least privilege of what is the bare minimum we need to move forward to provide the functionality that we're actually doing. So this is kind of like another summarization of this. You think, what would Peter Parker do with this? With great power comes great responsibility. So try to lock things down to the bare minimum so that you have less responsibility. And one other nice thing about this security breakout is usually people talk about security as like it's added weight on top of something. It makes things more complicated. In the case of application development, it actually makes some things a lot easier. So naturally, if I have a read-only user for some parts of my application, I've already separated out which parts of that can go to a different server. It doesn't have to go to the master anymore. I can have that go to like a replica to pull out the to query the replica instead. So if you're looking at the kind of the work effort involved in scaling out a system, if you already have a good security policy in place with separate users for read, for DML, and for DDL, the scaling out to add a new replica is just a matter of kind of updating that read database to say, okay, instead of going to our original, which is just a single source, now go to this replica over here instead. If you don't have security in place in the beginning where you just have one ID for everything, now you have to go through every single point inside your application and say, oh, could I change this one? Oh, maybe not. This is going to break something. You're going to break like transaction semantics about something. So just from the beginning, if you start from that point of saying, hey, let's do this right from the get-go, it makes life a lot easier when you eventually do have to scale out. So now let's switch over to actually connecting to your database. So when you're connecting to a database, you connect with the database driver. Database driver is the thing which actually talks to the database for you. So your application will have some kind of interface to the driver. It's usually something specific to your programming language. So if you're in Java, the interface would be JDBC. If you're doing it from Perl, I think it's like DBD, the interface. So it tries to present something that's specific to your language to make it kind of consistent how you're accessing the database. And it handles all the talking back and forth. It handles authentication. It handles actually ferreting your queries, getting the result sets back, parsing things. So there's two kinds of drivers. There's libpq drivers, and then there's native drivers. So libpq drivers use the library libpq, which is part of Postgres core. So it's developed as part of the project. The drivers which use it kind of leverage it as it's a C library, usually installed system-wide. And the drivers that use it kind of call out to those C functions to do whatever, to interact with Postgres. libpq has a lot of advantages because since it's part of Postgres core, it gets developed with Postgres, and it kind of has a consistent interface for how you're connecting and how you're interfacing with things. But native drivers also have advantages, namely being that since it's not a system dependency, you can upgrade them out of band. If you're kind of in the market for changing things yourself, like you want to add a feature to a driver, in my opinion, it's a lot easier to hack the native drivers because there's like positive sense of the word hack, in that you can change it because it's a language that you probably understand. If you're developing a Java application, you probably know Java. If you don't, you probably have other problems. But then you could actually edit the JDBC driver because it's written in Java. If you know Rust, you know how to edit a Rust driver. So here's some examples of Postgres drivers. If you're developing an application, you're likely using one of these or some other related driver. So one thing you have to do when you're, if you are the person responsible for an application is keeping your drivers up to date. Now, you get a lot of new things when you update drivers. So there's new features on the server that get exposed by the client. There's, just performance enhancements to the drivers themselves, for improved methods of batching, things like that. But one of the biggest things that happens with updating drivers is if there's a security issue in the driver itself, it's up to you to actually update that driver. So update your drivers. And the way to know if you should be updating your driver actually is just to get updates. So for most of the, for core Postgres itself, there's like an announced mailing list which lets you know when new releases are coming out. And then separate from that, for whichever driver you do happen to be using, there's usually mailing lists associated with that driver. So if you're using JDBC, there's like a GitHub list for getting notifications and its own mailing list. If you're using something else, you have to find out what it is, and it's up to you to actually sign up for that. And it really is like the bare minimum as an application developer. Since you're responsible for making sure that you're using these up-to-date dependencies, you should be the one signing up for this. Otherwise, if you have an application in production, if you're not updating it with a new version of these libraries and there's a bug in it, there's not necessarily any bug inside of your code, but it could be exposed by the driver itself. So just a question, does anyone here use Node.js? Hey, okay, one guy. Did you happen to see this? Okay. So this is a bug in the Node.js driver that I found a couple weeks ago. It was actually a pretty nasty bug. If you want to read up on it, it's on the site. But this is like the reason that you want to be updating your drivers. In this particular case, it was if you had a very, very nastily crafted query, it would turn into a remote code execution on your server itself just by returning that result set. So it is like a pretty extreme outlier of like bad things that could happen. But this is like kind of an example of why you should be updating your drivers and knowing about them, because otherwise it could be like months without you noticing that something like this is exposed. So now let's actually connect our database and see how that stuff works. So a big part of actually connecting to your database is making sure the connection itself is secure, and that's done using what's called transport layer security. So transport layer security, or TLS, it's also called SSL, and it's about encrypting the connection between your application and the database you're connecting to. So why do we need to encrypt connections? It almost sounds like, why do we have to ask this question? But the reason is you want to prevent eavesdropping, and we want to prevent man-in-the-middle attacks. So eavesdropping is when you're trying to communicate with something, and there's someone else who can listen into that conversation. So if you're using like a human example, you have two people in the room who are talking, and there's a third person who can kind of listen into that conversation, and they know what they're saying. The networking equivalent of this is I have two servers, one's talking to the other, and I have a third device on that network, like listening in promiscuous mode, and it's actually just collecting all the packets going on that network, and so it can hear all the bytes going back and forth. Now, man-in-the-middle is a little more complicated and significantly more devious in that the human example of it is, instead of me talking to the person directly, I'm talking to someone, and I have a third person kind of ferreting those messages back and forth. So, Alice tells Eve, hey, go ask Bob if he needs anything, and then Bob comes back and tells Eve, hey, tell Alice I don't need anything, and then Eve says, oh yeah, Alice said to give me 20 bucks. So Alice and Bob, since they're not directly communicating with each other, they don't know if that message is legit or not. So Eve is the one kind of manning the middle of the conversation there. So the network equivalent to that is if you're connecting from your application to your server, instead of you directly having the bytes go to the server, it's kind of going to a third location, and they're ferreting it back and forth. So the server thinks that the original client connected, but in reality, it's kind of controlling both ends of the conversation. So if you're trying to figure out if you should be using SSL, it's like a kind of flow chart to figure it out. So if you're connecting to localhost, you don't really need to use SSL because your bytes aren't actually leaving your computer. Presumably it's secure, and you can get there. If you're not connecting to localhost, you have to ask yourself, do you trust the network that you're connecting on? And what that means is the network itself, secure from someone else being able to either listen in or actually change the wiring. Imagine someone going there and like rewiring it so that the packets going from your application are going to going somewhere else as opposed to going to the database you're connecting to. If you're not sure, or just the answer is just no because it's a public network, let's say we're connecting over the internet to a cloud service or something, you really should be using SSL. If that's too complicated, a kind of simpler flow for that is just, are you connecting to localhost? And if you're not, you really should just be using SSL, so that way you don't have to think about whether it's secure or not. And if you want to go even simpler than that, just use SSL. The overhead of using SSL is actually pretty minimal for most use cases. That it's easier just to not think about it and just turn on SSL. And if you're not going to use it, then you can kind of think about that as like a opposite use case. So if you're connecting from libpq, there's a couple different modes in the libpq kind of driven off of either connection parameters or environment variables to dictate how you're going to connect in. So the top level one, disable, actually means don't connect with SSL, like explicitly use an unencrypted connection. And in that case, there's no eavesdrop protection, there's no man-in-the-middle protection, but you also know what you're getting. You're saying, hey, don't use SSL, I'm okay with that. Now, allow and prefer are kind of interesting because allow is saying, hey, if I have to use SSL, do it. But otherwise, just use an unencrypted connection. And since you're not actually saying which one it is, you don't know if it's going to be encrypted. Prefer is kind of the reverse of allow, where it says, hey, try to use an SSL connection, but if not, fall back to an unencrypted connection. And again, you still don't know because it could be an unencrypted connection. There's no guarantee. Requires where it starts getting interesting in that you're saying, hey, I need to have an SSL connection. But it's not actually checking to see, am I connecting to the right server? Because the way SSL works is, you connect to the server, it negotiates keys, but then there's also an added step afterwards where you verify, hey, am I actually talking to the person I think I'm talking to? And require just completely skips that step. It says, hey, let's just negotiate some keys. The wire itself is encrypted, but we're not actually going to verify who's on the other side. The other two options, verify CA and verify full, have that verification. So they actually check to make sure, is this the actual database I'm trying to connect to? Does the server, is the server who it says it is? Things like that. So those ones actually do provide man-in-the-middle protection. Now, this is how the modes are defined. If you actually go into the documentation, most of this page is actually copied from the Postgres docs. In the real world, this is what it looks like when people talk about enabling SSL. So you have some people that say, no, we're just not using SSL, and they'll have some kind of reason for that, where it's a lockdown environment, we control the network, it's localhost or whatever. Then you have people who have no clue what SSL is, and in that case, maybe it's on just because they copied a connection string from somewhere, and there's something SSL equals true and something, so eavesdrop protection's there. But there's no way that they have man-in-the-middle protection, which we'll get into a second why. Then you have people who explicitly know that they're using SSL, but at the same time, they're not actually checking, you're not verifying the server on the other side. So there is that, you're guaranteed that eavesdrop protection, but again, you're not necessarily verifying the server to know that it is the server that you think you're connecting to. And then that last category is the people who really understand the subject, and they've set up their own internal certificate authority, and all the certificates for their servers are signed by that, and they distribute the certificates out to the clients, and it's kind of its own league of really doing things the right way. And those guys actually have the full gamut of, we have eavesdrop protection, we have man-in-the-middle protection, we know this stuff works. From personal experience of, what you see in the wild, that third category is where most people are, where they know to turn it on, but beyond that, it's not actually enabled further. So, I'm going to go into an example now in Java, actually, how to, kind of what these different modes look like and how to use them. So in Java, it's a little different because it's a native driver and it doesn't use libpq. And the SSL configuration in Java is done with a number of different parameters. The first one just says whether or not we should be using SSL. And the other two dictate how to actually create that connection. So in Java, there's a concept of an SSL factory, SSL socket factory, which says how do I create the socket that's connecting to the server that you're trying to connect to. And the way that the JDBC driver is set up, you can specify your own custom socket factory instead of the default one. And you can also give it an argument if you want to customize it at runtime to do something specific. So by default, if you just say SSL true in Java, it's pretty cool because it does have eavesdrop protection and it does have man-in-the-middle protection. So on the surface, this looks like this is an awesome thing. Oh, I just have to say SSL equals true. The problem is this just doesn't work. And the reason it doesn't work is by default, it tries to use the JVM key store to do the certificate validation. And unless you actually did that, set up your own internal certificate authority, copied the keys out, loaded them into the JVM, and push that out to all your servers, it just won't work because then you'll get an exception saying that the Java application doesn't trust the server because it can't validate the certificate. So what ends up happening is people, they'll run into this error, then they'll ask on the mailing list, how do I connect with SSL? And then eventually they'll get to the point where they just switch it out, where instead of validating the certificate on their side, they say, hey, just use the non-validating factory. So this is the equivalent of that require mode inside of libpq. And this is saying, hey, connect with SSL, but just discard the concept of actually verifying the server on the other side. Just trust who we're connecting to. If the network itself is reasonably secure, you're not worried about someone being able to actually physically change the bytes that are moving around, this does work pretty well. So this will, on a local network or inside a VPC or something, this is a pretty legitimate setup. If it's not, though, since you're not validating the remote server, it is possible to man in the middle of the connection because you're not validating what you're actually connecting to. Now, if you do want to do that in Java, there's a number of different ways, and one of them is with this custom socket factory. So this single cert validating factory, what it does is it's kind of like a wrapper around the default socket factory, where instead of using the built-in one inside the JVM key store, you're saying, hey, here's the specific certificate for the server I'm connecting to, which if you know in advance which server you're connecting to, you can inject it in either as part of the connection string or have it available in your application. And then your Java app will validate to make sure, hey, am I actually talking to the server I think I'm talking to? So this factory is kind of cool because you can have it in the certificate in a file on the class path. You can actually put it as a string, like it's just a PEM encoded, like begin public key or public certificate equals whatever. So there's a lot of different options for kind of getting it in there. And it provides significantly more security than just that non-validating factory because now the client actually is verifying who you're connecting to. If you switch out that server with another server now, the client will immediately realize that because it's the certificate just won't validate anymore. So the concept, the name for what it's doing here is called certificate pinning, which is where you know the certificate of the server that you're connecting to. And since you know that in advance, you can make sure to validate that I'm connecting to that particular server. The next level of doing that is instead of having a specific certificate in there, what you can do is have a chain of certificates. So if you're familiar with the way that the CA model works for the public internet, when you get a certificate for your website, you're actually getting a certificate signed by VeriSign or Thought or one of those other companies. And it's, that chain of trust is what's how your browser verifies to make sure that this website is who they claim they to be. So a lot of cloud providers, and you can even set it up yourself to have like your own internal certificate authority, and then you use that to sign the certificates for your Postgres databases. And then when you're connecting in, you just have to have that one, that top-level certificate inside your application, and that tells me, hey, I trust all the databases underneath that have the same certificate. And, and if you happen to be using Amazon, they actually provide the chain on, if you follow the link inside the slides, there's the certificate for Amazon. Amazon's there for all their RDS databases, for Redshift, and everything else. So up until now, we were talking about just generic password auth, which in most setups happens with MD5 inside of Postgres. Coming soon in version 10, there's something called Scram authentication. It's a salted challenge response auth. It's basically just better than MD5 in every way. It's it has a the way MD5 works in Postgres. It's not that it's insecure, but the salt inside of it's like a relatively small salt. So this solves that and a couple other things. What's actually much cooler, but not in Postgres 10, but will hopefully be in Postgres 11, is that Scram also supports server validation. So that all that stuff involving certificates can just go bye-bye. Because what Scram allows you to do is say, OK, I know what the password is for the user I'm connecting to. Does the server know the password for the user I'm connecting to? Because if they do, then I know that it is the server, because if you consider that to be a shared secret. And you can actually use Scram to kind of secure the TLS connection itself to do that certificate validation step. So this is something I'm actually looking forward to in Postgres 11, because it will basically make it like trivial to have man-in-the-middle protection for SSL connections going forward. So kind of switching gears a bit, so this is Node.js right here. Can anyone point out what's wrong with this, this piece of code? And there is more than one thing, but there's like the one gaping really bad thing. Yeah. So if you look at where ID equals, I'm saying ID equals and like a single quote, and then I'm putting in whatever the user sent me in the request parameters. So this is like a classic case of SQL injection. So if you, instead of putting some normal thing inside the GET request, if I have this nonsense over here with like a quote, 0A, whatever it is, it'll lead to running this completely different table query over here, which really could be anything. So this is kind of classic case of how bad things happen. SQL injection is almost universally caused by, it's caused by composing SQL using things, using user input. And it's always bad, but sometimes it's like really, really bad. And how bad it is depends on what you're doing and how much, how much you've actually separated out the permissions for the users that you're using for things. But it's also really easy to avoid. So there's really two ways to avoid SQL injection. The first one is just use parameters for everything. If you have any kind of user input coming in, it really should be going through a parameter. You almost never should be composing SQL by just blindly concatenating strings together. But if you are doing it, you really should be escaping it. So we'll get into in a second what that means to kind of escape the strings there. So when you're looking in, when you look at SQL, there's really two kinds of, besides the commands themselves, the keywords, there's two kinds of fields. There's literals and there's identifiers. So literals are things like text. You have Postgres OpenSV in text. You have 2017. Null itself is actually literal. And these are things which can be parameterized in almost every context. There's one slight thing where you can't inside of do blocks, which is kind of annoying, but that's its own thing. But otherwise, in everything else you can do in Postgres, you can specify anything which is a literal value as a parameter. Now, identifiers are things like tables, views, functions, any object you create inside of the database. And these can't be parameterized. And the reason they can't be parameterized is when the parser is actually trying to evaluate what a command is going to do, it needs to know what the output of that command could be. So the output's not going to depend on what the parameters are, but it would depend on the type of the thing. So if you try to do something like select star from $1, where $1 is going to be replaced by by an actual table, the result's going to change. If it's a count, it might have 3 fields. If it's people or person or something, it might have 10 fields. So since the parser needs to know what that output is before it starts evaluating the query itself, you can't parameterize identifiers. But literals you can. So if you look in that first example there, we have select where ID equals $1. And $1 is a placeholder in Postgres using numbered parameters for, for what that value is going to be. So here's an example that kind of similar to what we were doing before in Node.js of how to use parameters. So almost every driver inside of Postgres has some interface, and the dynamic kind of dynamic language will be very similar to this. Postgres uses numbered parameters. So what that means is you can have a $1, $2, $3, and when you're executing a query, you can say, hey, replace the $1 with this value, replace $2 with this value, which in this case we're doing by that array over there where it says the username is saying replace $1 with that username value. So if you're doing the same thing from Java, it's similar but different. Java has the annoyingness of trying to match up with the JDBC API, which doesn't have a concept of numbered parameters per se. What it has is placeholders for parameters, which is what those question marks are. You would think it's kind of the same, but it's actually worse because there's specific situations where if I want to reuse a parameter in Postgres, I can say $1 in like 10 different places in the query, and I only send it once when I'm executing it. Whereas in Java, it actually requires you to have like 10 question marks, so you can't tell the difference between them, so you'd have to specify it 10 times, so that's kind of annoying. But otherwise, it is pretty similar in that you're saying, hey, parameter, that first question mark is that $1 equivalent, and set it to that string for the ID. So the other kind of parameter is what's called name parameters. And out of the box, Postgres doesn't support name parameters. It only supports numbered parameters. But there's a lot of libraries, for almost every programming language, which provide name parameters on top of that interface that they're providing. So this is an example from Spring JDBC for Java, where instead of having $1, $2, $3, I have name parameters for colon name, colon year, and it's a little easier to understand what's going on because I say, oh, I'm setting the name parameter to be Postgres Open, the year to be 2017. If you're trying to do like in this like simplistic example, you could say, oh, it's not that different from like 1 or 2. If you have like a huge SQL statement where something's just buried inside like a $1, and you're trying to see what the value is for it, it's much easier to catch like errors of what this thing is supposed to do if it is a name parameter, because then you don't have to kind of figure out, hey, what did $1 refer to in this particular context. So if you are, if you do happen to be composing SQL using identifiers, like I want to put together like a reporting system that says, hey, the user gives me a table name, I'm going to run a select star on top of that table to bring it in. You have to make sure to escape those identifiers. So what that means is you call this function, in Java, it's a function called escape identifier on the connection. And what that function does is, if you give it like a table name, it'll give you back the table name in a way that you can inject into a SQL statement that's not going to, that would be properly coded. So if that table name has spaces in it, it'll wrap it in double quotes. If it has quotes inside of it, it'll escape those quotes. And this function is part of the connection on the PG connection class. So if you want to do the same thing inside of like Node.js, it's not built into the driver the way it is in Java, but Node.js has like thousands and thousands and thousands of packages like separately. There's a really nice one called PG format, which if you're familiar with the equivalent format function inside of Postgres, there's a PGSQL function. It's almost like the mirror image of that function. So this is actually much more powerful than the Java version of it, because you can give it a full string to say, hey, select star from, and that %i gets replaced as an identifier, the %l gets replaced as a literal, the s gets replaced as just as is as the string. So you have like the full ability to compose anything together, and it makes it much easier to actually put something that's not going to blow up in your face, because the things that want to be escaped are going to be escaped, and the things that shouldn't will not. So one other kind of general, a lot of this stuff you'll see it's just general guidelines for application development, but making things easier actually makes things more secure too. So when you have SQL strings inside of source code, my rule of thumb for this is if you can't just fit it on one line with like a very small number of things being accessed, like one table, one column, one where clause, it probably shouldn't be there. So a lot of the times when you're accessing a database, if you're going through an ORM, all this stuff is all this stuff is kind of abstracted away from you. The ORM is the one that's generating the queries. You don't have to worry about the actual SQL composition of the SQL. But almost every application kind of gets to that point where that, for the secret sauce for that app, whatever you're doing, it just doesn't cut it to go through an ORM. You end up having to like compose SQL together. And if you have that one-liner, it's it's something that if you just look at it, okay, this looks okay, it's getting the name, there's nothing funky going on here. When you start getting like multiple lines inside of there with like multiple things happening, not only is it not only is it hard to understand what's going on when you see that inside your app code, it actually looks really bad inside of your app code too. So some programming languages have like better stringing lining than like Java, let's say, but I've seen way too many applications, where you look in and there's like a diff or something inside of the code, and it's like a diff of string composition, and there's no syntax highlighting, and the thing's inside quotes, and you can't really tell what this change did or whatever it is. And that's the kind of stuff that leads to bad string composition for SQL. So how do you avoid this? One easy way we found is you just have a directory of SQL files. I mean, this seems like one of the simplest things that you could do, but it actually works really well. And all this is just a directory where inside that directory you have a file, and each file is just one command or one query or one whatever it is. And it could be something with like 2 lines, 3 lines. It could be something with 10 lines. It doesn't matter. And what's particularly cool about this is it doesn't matter what language you're using to access it either. So if you want to access this from from Java, you can have a really simple wrapper that says, hey, just load the SQL. And the naming structure for what you're loading is just the directory structure, and you don't have to put the .sql on there either. Just load the foo, find by ID, or whatever it is. Same thing for Node.js. If you happen to be running an application which has multiple programming languages, it's particularly cool because you can share this across multiple languages. So if I have some query, if it's hard-coded in this Java file, it's also inside of this Go file, it's also inside of this Node.js file, I have to change it in 3 places. Whereas if I have it in one place and it's externalized, I only have to change it one place. I know everywhere else is going to get it at the same time. And when someone's looking at the diff of, hey, Sehrope, what did you change on this thing? You immediately see just the lines that you changed. So again, this isn't, these are the kinds of things that make it easier to actually keep your code secure, because you're separating out the stuff which is SQL related from the stuff that's just purely application related. So I'm going to give one more quick example over here. So if you look at this, this code right here, I have a SQL file, it's performing a function call, and then I have a name parameter template over here where I'm executing this function. Can anyone point out what could go wrong in this situation? No takers? I mean, the hint on the board is, it kind of gives it away.
So you can do SQL injection on name, it looks like.
So the name is being passed as a parameter.
Oh, okay.
Yeah. So the thing is you don't know. And the reason you don't know is I haven't said what that function does. So if I'm just calling something, I could be invoking something with a parameter. It could be a name parameter. But if you don't know what that foo-baz function is doing, it could be composing SQL internally. So as the application developer, it's your job, if you're invoking something inside, to know kind of all the way down how safe is this thing going to be. So kind of wrapping up the kind of topics we went over here. You want to minimize the privileges for what your thing does, because that tiered approach we were talking about, that defense in depth, if something does go wrong, if you do have a SQL injection inside of your application, if it's done with a read-only ID, you don't have to worry about dropping your database. So it might be bad. You will have data exposed to someone if there's a bug somewhere, but you're not going to delete everything. You're not going to drop your database. You're not going to make catastrophic changes. If you're not updating your drivers, you really should, and you should get notifications for it. If you're not using SSL, or you don't know if you're using SSL, it's something you should also check on. Again, there's no reason not to be using it, unless you're in a very specific situation, in which case you know exactly what you're doing probably. And just be using parameters for just about everything. There's, unless you have a hard-coded constant inside your query for the actual thing that you're executing, all user input should be going through parameters. There's no excuse really for it not. And I'm a big fan of doing everything with name parameters, because I think it makes the code more legible for whatever you're reading. And then finally, for externalizing SQL, it just makes everything a little easier to work with, because at that point, you're only dealing with the SQL itself, kind of on its own. If you want to get fancier with that externalized SQL, what you can actually do is run static analysis on it, and then see if the outputs for the queries that you have in that externalized SQL matches up with the uses inside your application. So I don't have it as part of this presentation, but if you want to talk to me afterwards, there's some really cool stuff you can do with dynamically generating that off of the SQL, and then doing type checking inside of your app to see, hey, when I read this name column, am I putting it inside of a number, is it inside of a string, and whatnot. So with that, any questions? Going once, going twice. Sold.